Well, we're talking about industrial, and we're somewhere around 20 degrees C in our setting here. But I imagine, besides temperature, there's a lot of things that go on inside a warehouse or inside a factory floor that might make it a harsh environment. Greg, could you share a little bit about what you see AMR is doing in the industrial context?
Absolutely. So there's things to consider like shock and vibration. Things may be falling, things may be moving, things are really paying attention to waterproof IP67 solutions and also eliminating a lot of the dust that's going on in this environment.
So everything that you do is focused on making sure that within the context of whatever the environment is, it's rugged and robust enough to stay working.
That's absolutely correct. We want to make sure that everything from an operational perspective is taking into consideration all the environmental aspects.
So Matt, we've talked a little bit about some of these harsh environments, but I know that we're in this environment of the industrial Internet of Things, where a variety of communications, whether they're wired or wireless, is going on. What are some of the important considerations we have to take in this realm for industrial Internet of Things?
Yeah, it's a really good point because you really do have two aspects. You've got the wired aspect, which is the internal components of the robots themselves, so the pickers and the placers and things of that nature, where you've got to have these wired solutions to allow it to do the motions that it's doing. In addition to that, it's the communication aspect and the telemetry aspect that we mentioned before, in that it needs to be able to go back and forth and know where it is and know what it's picking and know what it's placing. So this combination of these two different types of wired versus wireless are really coming together for the overall solution for the warehouse.
And you're making sure your solutions then on the RF are robust enough to ensure that no matter what the situation in the context is, it can withstand that.
Yeah, without question. I mean, there's a lot of customization that go into these types of product, and some of it might be a latching mechanism that there's. In some cases, it's key coding to prevent mismating of multiple connections within the same solution, and then sometimes it really is a ruggedization aspect of it. And then there are times when it's just the particular robot they have require a slightly different length or a different orientation, right angle versus straight, something like that, and we're able to provide all of those different versions.
Gentlemen, I want to ask you, we're talking about autonomous mobile robots. They got to be able to see their way around. They got to be able to know where they are, to have this spatial awareness. Could you talk to me a little bit about what type of solutions that you have that gives this spatial awareness that helps make that all a reality?
Yeah, so a lot of cases we're providing solutions that are connecting to different, what we call general purpose I/O, which in a lot of cases are peripherals or sensors or camera systems that basically allow you to be able to see where in the warehouse setting that you're moving around and different interactions with other robots, and really be able to show the versatility of the system itself.
Matt, if you would, I want to go back to this IIoT and this wireless communication. Can you lay out for our viewers what are some of the common technologies being employed, and why would people use that in the industrial setting, and how those come to play with AMRs?
Sure, absolutely. I think in a lot of cases we're adapting existing technologies that we know work. Certainly there's been the ruggedization and miniaturization overall, but if you really look at the overall ecosystem, we're selling everything from the standard AMC board connector, which is an ultra miniature connector, all the way through the micro connector up to a traditional I/O, whether it be an SMA or a TNC or anything along those lines. So as this IoT space comes to fruition, it really is adopting current technologies and applying it where it makes sense.
So some current technologies are things like Bluetooth and Wi-Fi and 5G.
Yeah.
Could you share a little bit about some of those specifics and where you see them?
Sure. There's what you just talked about, right? And then in addition to that, you've got the GPS aspect, you've got the visualization aspect. We've had applications where they actually use it as a camera. So for example, a forklift driver could lift up to a top shelf and he's able to see on his heads-up display what he's looking at. So those sorts of situations and those sorts of products have really come to fruition. And then there's been some other developments. For example, we actually manufacture camera backs, which is something we've never did before, where the customer has the camera, we'll manufacture the camera back itself that has the RF connector built into it, so then they can just connect in and go from there.
I understand. Greg, we talked about higher density and some of those small pitches. Talk to me a little bit about any applications you have with sub-miniature type of packaging.
Yeah, so I think certainly with our products, versatility is important, and miniaturization, I mentioned before the size of the connector. I think that's important in many cases where the the main goal is to hold the biggest load with the smallest package size within the robot. So in a lot of cases, our product solutions are being able to adapt to different connections, different signal counts, different power requirements, and I think a lot of those have comparisons to automotive, as we talked about before.